Okay, I'm going to do 1987 here for response. The first one is determining the equivalent resistance of the three resistors. Okay, so first thing I'm going to want to do is combine my resistors. I'm going to focus on these parallels because they make me annoyed and nervous. So I'm going to, well, actually, before I even start, I'm going to label my resistors so I can keep track of everything. A, B, C. Okay, so doing that, I'm going to want to get the equivalent resistance, and I'm going to do it for A and B. I'm going to combine them. So 1 over 4 plus 1 over 12. And math, that gets me the equivalent resistance for A and B is 3 ohms. If you didn't get that and you got 0.333333, you forgot to flip it. It's 1 over that. Okay, so that takes care of this one and this one. What I have left is that 9 ohm. So I'm going to get the equivalent resistance for A, B, and C. And since those will then be in series to one another, it'll be 3 plus 9. And math, 12 ohms. A is done. I have not completely failed the circuitry for your response. Yahtzee. All right, let's go look at the next thing. Determine the EMF of the voltage of the battery. Okay, so for B, we're going to use handy dandy V equals IR. We're looking for that voltage, which can also be written fancy pants. We'll talk about that later. They gave us the current through the 9 ohm resistor. Okay, now since that 9 ohm resistor is in series to the battery, you can tell that that thing is going to take the full current of the battery. So we're going to have a current of 0.4, and the total equivalent resistance in this circuit is that 12. So we end up with 4.8 volts. Okay, part C, there's a few ways to do it. Let's see, which way do I like the best? I could probably do this. Okay, earlier on, I went and I combined resistors A and B, and I found that their combined resistance together was 3 ohms. So what I can do is I can say, okay, C, okay, is equal to V is equal to IR. So what I'm really looking for is what is the voltage drop between here and here? In other words, what voltage drop is going to happen between those 2 points? So V is equal to, if I combine those two, combined, they're going to have the full current going through them. I don't know how much is going to go into each branch, but combined, they're going to have 0.4 flowing through them. Oh, I should be careful with my labels. A, B. And the resistance going through there, the equivalent resistance was 3. Okay, and that gets me 1.2 volts. So each branch here, this way, if we're going from this path or going along this path, you're going to have a voltage change of 1.2 volts. You can't make free energy, so no matter which path you take, that's going to have to be true. So they are specifically interested, oh, actually we're done. I didn't even read this. The potential difference, so it's going to be 1.2, and draw a smiley face. Okay, the hardest thing about power is that there are several power equations for part D. They want you to find the power in resistor 1. So P is equal to VI, P is equal to I squared R. Okay, and the last guy is P is equal to V squared over R. Totally worth memorizing. Okay, so then this is going to be a simple plug and chug. Power is equal to, we know the voltage drop, we just calculated it, 1.2 squared divided by the resistance. The resistance is 4, and we get 0.36. Okay, last but not least, in part E, they want us to determine the amount of charge that passes through resistor 3 in 1 minute. Okay, please keep in mind that when we talk, and this is very important and why you always need to read your notes, current is equal to the number of coulombs per second that pass by him every second, every moment. Oh my gosh, I'm saying that terribly. The basic idea is coulombs is amount of charge, okay, and seconds is time. That's actually what amperes means, or amps mean. So we know the current was 0.40, okay? That's how many charges occur every second. But we don't want it to occur every second. So we're going to multiply that by 60 because it's going to be happening for 60 seconds, 1 minute. And that should get your answer.